Welcome to another episode, and today we're going to talk about Tezlink. For some of us, it's still a bit of a mystery, so let's start from the beginning. Let's start with why and what is Tezlink.
First of all, Tezlink is a tentative name. It may be called something different. I don't know. But essentially, today, if you want to use a Tezos blockchain for smart contracts or for applications, you have two options. You can deploy traditionally on a Tezos blockchain using your Michelson and languages like SmartPy and jsLIGO, or you can deploy in an EVM environment using Etherlink. Those are your two options. And it's great to have options. But Etherlink brings some advantages that don't exist on L1. Notably, very low latency, the ability to scale using the data availability layer to even more performance, more transactions per second. And also now you have a nascent ecosystem of DeFi on Etherlink. And so you don't want people to have to choose between one and the other, right? It would be nice if you could have all the benefits of building in Michelson, building with jsLIGO, building with like SmartPy, and the benefit of having this very low latency, and the benefit of being able to tap into the liquidity and all the other stuff that's being built inside, Etherlink. Can you, use the traditional development environments for Tezos, but also have access to all the bridges, all the services which are on Etherlink? And the answer is like, yes, you can. And that is what Tezlink does. So Tezlink essentially brings all of the Tezos execution environment. I don't want to say into Etherlink. I would say it's more of like you end up with a bigger rollup, and that bigger rollup has a component which is Etherlink, which is the EVM view on it, and with Tezlink, which is a Tezos type view on it. Think of it as an object casting shadows, and you can have this object, which is this unnamed rollup. Maybe it's like a proto Tezos X rollup. And then if you shine the light on it in a certain direction, it casts an EVM shadow, and that EVM shadow is Etherlink. And if you cast the light in another direction, it casts a different shadow, and that shadow is Tezlink.
It's very modular approach to what we have currently. And I assume that Tezlink will be one of the modules. And when it all comes together, what will happen with L1? What will be the role of L1 and everything that is currently on it from the developer perspective?
I mean, from a developer's perspective, I think you're going to be able to keep using L1 as the way you've always been able to use L1. But in terms of new development and where specifically scaling is going to be pushed, lower latency, higher throughput, perhaps also like integration with middleware, that's more likely to happen in Tezos X. Layer 1 keeps working. You can deploy on Layer 1. But I would say most people will find it advantageous to deploy in this network extension.
Is there any way we can migrate the existing ecosystem into Tezlink, for example?
There's a few ideas that have been floated around. One of the ideas, the most radical one, would be take the L1. Now the L1 only does four things. Consensus, the data availability layer, adjudicating rollups, and then transfers, because if you're doing staking, you need to be able to do transfers and bridging, and that's it. Nothing else. The benefit of doing that is you get to cut a lot of the functionality out of the code. You can simplify a lot the code that lets you drop your latency, so you have faster finality. The way you could provide compatibility is basically take the entire state of the L1, just move it into Tezlink or just move it into Tezos X. From a technological perspective, it's probably the most elegant solution. From a community perspective, it's a bit messy because people have different conception about what a rollup is, what an L2 is, what an L1 is. Ultimately, I would argue that no one should care. They should care that it works and that it's secure. People use applications on their CPUs. CPUs have L1 caches and L2 caches. Unless you're writing in assembly language or really optimizing your program, you do not care about L1 and L2 cache on your CPU. Like no one who just logs into the computer and launches their browser cares about L1 or L2 cache. No one who uses applications on a blockchain should deeply care. Today you should care, because if you're using an Ethereum L2, for example, you're using a custodial solution most likely, or maybe you have to deal with bridges. But in a system that's well designed, well integrated, and secure, it shouldn't matter at all. But in practice, I would say, given the timeline at which this might happen, it's probably not worth it. So it's probably worth it to just keep the system in the current form that it is. Essentially, because the scaling happens mostly on Tezos X, over time, with compute becoming more and more performant, you can optimize your L1 in different ways. So yeah, probably nothing happens essentially to the L1. Of course, some people who are in L1 might say like, wait a second, I want to move. And if we lived in a world where people deployed completely decentralized contract, that could be an issue. People will say, no, I have this completely decentralized contract that's entirely on layer 1. And unless it's migrated automatically to Tezlink, it will never have all these advantages. We're not in that world. All of these applications have upgrade mechanism, upgrade keys, they can be migrated. Even without moving the contract, you can redeploy and tell your community, hey, by the way, move your liquidity over there. In practice, it's fine. The cases you would have to imagine where it's important to have automatic migration are really kind of far-fetched and just don't match what you actually see on blockchains. If people want to use Tezlink, they can use Tezlink. If people want to keep using the L1, they can keep using the L1. But like development focus in terms of like performance gets focused on Tezos X.
Okay. So for example, one of the questions from the community was what will happen to my art as an artist on Tezos?
I think in an ideal world, no one would care if you are on, Tezos X or Tezos. Like they would care about performance and cost and security. But in practice, people do care. And so as a result, no automatic migration. So it just stays on L1. I would say also, ultimately, what I say doesn't really matter because Tezos works with on-chain governance.
Yeah.
And so, things don't get adopted unless there's a widespread consensus for it. If anything is really disliked or a concern for people, it simply just would not be adopted as a protocol amendment. So that's kind of the end of it.
This is how we roll.
Yeah.
Yeah.
It's a much better protection than whatever I happen to be thinking.
There are, of course, some case studies that Tezlink will enable that were not possible to do with L1. How would you imagine the very next, let's say, step for Tezlink to enable something that's not possible on L1?
Two things that I mentioned, right? Low latency and then also compatibility with Etherlink. So it's much easier to, for example, get integrated with something like layer 0 for bridging than it is to get it for L1 because it's an EVM type of chain. But now, if you have Etherlink and Tezlink, running inside the same rollup, and you have part of it that's kind of connected to a bridge, then immediately you get the benefits of that bridge into Tezlink. So it's really benefiting from this interconnectivity and this like inter-chain connectivity, all these middleware services, custodians. If you have a token, for example, on Tezlink, and you say, I define a custody solution, very easy to say, the token just like instantly bridges to Etherlink. Now it's like easier for exchange listing, it's easier for custody, it's easier for all of that, but you can use a programming environment you want. An open question, I would say, for Tezlink is what type of interop it has with Etherlink. It's clear that they are working in sync, so you can do instant transfers. The question is it enough to have instant asset transfers between the two? Which gives you like a lot of the interop that people want. If you can trustlessly bridge assets instantly, that's already great. Do you also want to have inter-contract calls, like Michelson contract, call in, EVM, calling back Michelson, all of that? It's doable, it brings more complexity. So it's an open question where the sweet spot for that is.
It's a good question for our audience. How you see the future of Tezlink, of everything that is related to this growing ecosystem of rollups, because we have Justice, we have Tezlink, we have Etherlink.
A whole Tezos X.
Thank you so much for this conversation. And
thank you.
Yeah, it was a pleasure like always.
Likewise.